Hello everyone, I am Dr. Subhasish Saha, Assistant Professor in Physics, Department of HNS, MLR Institute of Technology, Hyderabad. So today I will discuss about the concept of nanomaterials. So what is nanomaterials or nanoparticles? So before going to that, I will just give some overview of today's topic or lecture. So concept of nanomaterial, then quantum size effect, surface to volume ratio or aspect ratio. Then we go to discuss about quantum confinement. So what is nanomaterials? So in nanomaterials, we know that in Greek word nano means it is a very small. So what is the meaning of small? Small is the order of it is the order of nanometer, which is basically 10 to the power minus 9 meter. So nanomaterials has size which is the order of nanoscale, or we can say it is 10 to the minus 9 meter. So any one of the dimension or more than one dimension, if it is in nanoscale, those particles or those materials called nanomaterials. So which means nano means 1 billion of 1 meter. Okay, so this is the order of nano scale. Now come to the bulk to nano. Okay, so it is a transformation from bulk material to nanomaterial. So what is this transformation? Suppose this is a bulk material. So it is like a cubical box, have three axis or three dimensional box, x, y, z in 3 dimension. In all directions, the scales or dimension is macro order. Okay, it is macro order in bulk order. Now suppose we transform from bulk to nano. So there are 3 types of nanostructures. First is quantum well, second is quantum wire, third one is quantum dot. So what is quantum well? Quantum well is if suppose a material has only one dimension, only one of the dimension is in nano range. Okay, that is called quantum well. So this is a suppose a diagram. So it is a bulk material. We are transforming to nano size. So any one of the dimension, suppose these are in bulk order or range, but this one is in nano range. So any one of the dimension goes to in nano scale or nano range. So that is called quantum well. Second is quantum wire. Quantum wire is any material has 2 dimension are nano range. So in this case 2 dimensions, any 2 dimensions is in nano range or in nano scale, that will give quantum wire. So in this case we notice that this one and this one is nano range, but this one is so 2 of the dimension is nano range and height one is bulk order or bulk range. So that is quantum wire. Last is quantum dot. So this means quantum dot means in this case all 3 dimensions are in nano range. All dimension is in nano range, that is called quantum dot. So this means nano means it is nanoparticle. It is basically the order of 10 to the power minus 9 meter, the range or dimension. So the material has 3 types of structure. Quantum well, any one of the dimension, if it is in nano order, then it is called quantum well. Any 2 dimension, any of the 2 dimensions is in nano range, that is quantum wire. Quantum dot is if all 3 dimensions is in nano range, then it is quantum dot. So these are transformation from bulk to nano in different directions, corresponding to gives a structure of the nanomaterial. So these are the structure of the nanomaterials. Now why it is called quantum? Before I will discuss about these things, why the name is quantum. So before going to that, just I will discuss about, before going to that discussions, I will just discuss about the surface to volume ratio or aspect ratio. And when we discuss about those things, automatically the point will come quantum size effects. Quantum means, why I will telling quantums? Because when you reduce the size, okay, when you transform from bulk material to nano materials, when you reduce the size of the materials, lot of properties will be changed like physical properties, chemical properties, mechanical properties, electrical, opticals. Those properties will change for this material. Okay, and to explain those properties, we have to take care of the quantum phenomena. At that times, we cannot directly treat it as a particle, rather than we have to treat it as a wave. To explain this phenomena, how these properties change, when to explanation for those things, we have to introduce the concept of quantum mechanics. That's why it is called quantum size effects. Now, if you reduce the size, so lot of properties will change. I mentioned electrical property, optical property, chemical property, magnetic, thermal property. So these are the properties is change, and to explain those things, we have to give the concept of quantum mechanics, where actually particle treated as a wave. So one of the important property I highlighted in bold, that is chemical reactivity. So what is chemical reactivity? Basically take care of the rate of reaction. Reaction rate is taken care. Now in chemical reactivity, when you talk about the chemical reactivity, so chemical reactivity increase with the decrease of size of the material. Suppose we reduce the size of the material, the reaction rate will increase, as well as, because why? Because the surface to volume ratio will increase when you decrease the size of the material. So this means what? Suppose you reduce the size of the material, so then the surface to volume ratio will increase, as well as the reaction rate will also increase. The reactivity, chemical reactivity will also increases. Now, what is surface to volume ratio? And it is a very important property of nanomaterials. Now, what is surface to volume ratio? Suppose this is a nanoparticle. Suppose it is a spherical shape. Okay, it is a spherical shape. So these spherical shape nanomaterials or nanoparticles having spherical shapes, where having radius is r, then the volume is 4 by 3 pi r cube. It is a volume, and the surface area is 4 pi r square. This means surface by volume ratio will comes 4 by 3 pi r cube divided by 4 pi r square. This means it will gives 3 by r. So this surface by volume ratio is inversely proportional to r. Okay, this means if the size of the particles is reduced, this surface to volume ratio will increase. So this means if we go from bulk to nano, then the radius will be decreased, and the surface by volume ratio will increase. If the surface by volume ratio will increase, the chemical reactivity will, or reaction rate will increase. So how it is, we can explain these things. For explanation purpose, we come to this point. Suppose there are 3 nanoparticles. This particle 1, particle 2 and particle 3. Particle 1 having radius is 30 nanometer, and particle 2 is radius is 10 nanometer, and particle 3 is 3 nanometer. So in this case, particle 1 radius is 30 nanometers. So this means 5% particles is on the surface. Okay, the number of particles on the surface is very few. 5%, suppose it is only 5% particles are located on the surface, and 95% are inside this material. So 95% is inside this material. Since now the reaction rate is depends on the how many numbers of particles are located on the surface of the materials. Only those particles actually has taken care for the reaction rate. Which are located on the surface, those are actually involved to the reaction. So this case, since only 5% are there, so there in this case reaction rate will be low. Compared to this, particle 2 has diameter is 10. In those case, 20% particles are on the surface and 80% particles are inside this material. So since the number of particles on the surface is more, the reaction rate will be more for particle 2 compared to particle 2. When you come to the particle 3, so in this case radius is only 3 nanometers. So most of the particles, suppose 50% particles inside this and 50% is located on the surface. So in this case, since the more numbers of particles on the surface, so those will take care the more reaction rate. So this means when you reduce the particle size, so in this case reaction rate will increase, and when you reduce the particle size, the surface by volume ratio will also increase. So in this case we can say, if we reduce the size of the particles, surface by volume ratio will increase, as well as the reaction rate will also increase. Okay, so this is the important discussion about the surface to volume ratio. It is not only that for only chemical reactivity, lot of other properties like solubility, then reactivity, stability, in those cases also we can discuss in such a way. Now come to the next topic or next discussion. It is quantum confinement. What is quantum confinement? Before going to that discussions, I already mentioned why it is called as quantum. Quantum name is given because of these properties can be explained from the phenomena of quantum mechanics, where we treated the particle as a waves. So in this case, what is quantum mechanics? Before going to that, suppose this is a energy structure of semiconducting materials. It is a bulk material. We know in a semiconductor material there are two kind of band is there, valence band and conduction band. How this band is formed? Usually when we increase the number of atoms, suppose one atom is there, corresponding one energy levels is there, now energy levels corresponding to electrons of this atom. Suppose I bring another energy another atoms corresponding to that, another energy levels will come. So if we come to more number of atoms, if we increase the more numbers of atoms, the energy levels having the same energy values or closely, those energy levels are close, those energy levels are almost very close to each others. If we increase the more numbers of atoms, those are very close and makes a band. We know about this. This is a classical approach to formation of band, right? So in this way, valence band and conduction band is formed. Valence band is basically the electrons in the valence orbits is there. So those electrons energy, those orbitals, suppose one atoms is there, okay, this is one, this is a suppose atom's nucleus is there and electrons are evolved. So in the orbit, suppose this is a valence orbit electron, the energy levels corresponding to this orbit is called valence orbit, and suppose these atoms, several atoms are coming, the valence band is constructed from the valence orbits. Suppose there are lot of atoms are coming together and the energy levels of all valence orbits are come to close each other, and that makes it valence band. Suppose there is a one atoms, let's say sodium. In case of sodium, we know the atomic number or atomic configuration is 1s2, 2s2, 2p6, 3s1. So this is a case of sodium. So in this case, the valence orbit is 3s1. So the energy corresponding to this valence orbit has one energy levels. Suppose this one sodium atoms corresponding one energy levels, valence orbit 3s. Next is 3p. 3p is empty. So this is valence orbit 3s, one energy levels. We come to the another sodium atoms corresponding 3s of another sodium atoms are having close energy, that is another energy levels. Another one, another atoms corresponding to valence energy is another 3s. In this way, when we come to the lot of atoms, so those are makes a band. This band is called valence band. And above this 3s, 3p orbit is empty. Okay, this empty orbits also forms a band. Okay, those are makes a band, that is conduction band. Okay, valence orbitals, energy bands corresponding from the constructed from the valence orbitals, that is valence band, and the above valence orbitals, empty orbitals is there, where is no electrons is there, those are energetically comes close to each others, and that is makes a band, that is conduction band. So in this way there are two bands, valence band and energy band. Valence band is occupied by the valence electrons, valence electrons. Okay, so this is the diagram or band structure of a suppose a material, bulk material, valence band and conduction band. In between them there is a energy gap is there. Okay, so we got the classical pictures of the what is valence band, what is conduction band, and between them there is a energy gap. Now suppose we reduce the size of the material, we reduce, okay, decrease the size of the material, okay, reduce the size of the material. Okay, if we reduce the size of the material, okay, if we reduce the size of the material, then what will happen? Suppose when the lot of atoms are close together, those are makes a band. Suppose now if I reduce the size of this material, okay, then what will happen? this spacing will increase in this valence band and conduction band. Okay, so that bands now make it discrete energy levels. Suppose we reduce the energy bands, means the energy levels will also decrease because there are less numbers of atoms are close to each others. So it will reduce the energy levels, and as well as what will happen, those energy levels, now it's not a band, it is like a discrete energy level. This is valence band, but the energy levels are discrete because you reduce the size of, if you reduce the size of the atoms, this means you reduce the numbers of atoms. If you reduce the numbers of atoms, if we reduce the numbers of atoms, then the energy levels will be makes now start to discrete rather than band. Okay, it is very clear that if we increase the numbers of atoms, let's say in another way, suppose we increase the numbers of atoms, means those energy levels are comes close to each other, makes a band. Now if you reduce the size of the material, this means you removing the atoms. If you removing the atoms, means again those are makes the bands. Now those are, now what will happen, if you reduce the atoms, then energy levels is also removed. If the energy levels are removed, means that makes it discrete energy levels. Okay, if we make these discrete energy levels, then what will happen, the energy gaps is also increase. Okay, if you reduce these atoms, numbers of atoms, means if you go from bulk to nano, reduce the numbers size, reduce the size of the material, this means you reduce the numbers of atoms. So when you reduce the numbers of atoms, means energy levels now start to make it discrete levels. When you make the discrete of energy levels, these gaps is also increase. When the gaps is increased, then what will happen, usually in valence band electrons are occupied. Okay, and the conduction bands holes are there. Now since the energy gaps in increase, means these electrons cannot easily jump from valence to conduction bands. Okay, those electrons are stuck or isolated in the valence band, and holes are isolated or stuck in the conduction band. So this means electrons and holes are confined. Electrons are confined in the valence band and holes are confined in the conduction band. So in this way it cannot easily jump because the energy gaps is increased. When the energy gaps, in this way we can say it is a confinement. So what is this? The statement is, when the size of the semiconductors decrease, then the energy gap between valence band and conduction band increases, due to which electron and hole, called exciton, a pair of electron and hole confined in discrete energy levels, okay, they cannot easily jump. This confinement of electron and holes is known as confinement effect. So it is a sense of confinement. What is the sense of confinement? Confinement means initially when the bulk size is there, when the bulk material is there, we know there is a valence band and energy conduction band is there, there is a gap. Now suppose we decrease or reduce the size of the materials, then what will happen? If you reduce the size of the materials, means if you are removing the atoms, means corresponding the energy levels is also decrease. Then these continuous energy bands now transform from band to discrete energy level. This is the diagram comes from the valence, but decrease in size. This is also conduction bands shifted to discrete energy levels, as well as when the numbers of atoms is decreasing, the gap between them is also increased. So in this case, these are the less numbers of discrete energy levels in the conduction band, and this is less numbers of energy levels in the valence band. And we know conduction bands is occupied by the electrons. Since this discreteness is there due to the decreasing the size, the energy gaps will also increase. Since the energy gaps are increased, electrons cannot easily jump, rather than those are stuck or isolated in the valence band, and holes are stuck in the conduction bands, and those are cannot easily jump. So we can say those are confined into this into there. Okay, so in this way you can introduce the concept of confinement. Okay, now we already discussed about confinement is the structure of the nanomaterials are three type of confinement: well, quantum wire, and quantum dot. So in case of quantum well, only one of the dimension is confined, other twos are free or in bulk order. So in case of quantum where any two of the dimension is confined, one is bulk order. In quantum dot, all of the three dimensions is in nano order, all are confined. So we can say there is a two things, one is degree of freedom, another is degree of confinement. Degree of freedom means independent direction of motion of electrons, means that is in, we can similar to map with the bulk, means electrons can freely move in any direction. So that is called degree of freedom, degree of motion of electron, okay, independent of the direction of motion of electron, that is degree of freedom. Degree of confinement means it is in nanoscale, means it is number of direction of confined motion of electrons, means it is introduce the concept of confinement, means electrons is confined in nanoscale. So in case of bulk, all three dimensions are freedom, degree of freedom is 3 because all three dimensions are bulk order, so it is 3. Degree of confinement is 0, so total is 3. In case of quantum well, one dimension is confined, two are in free, so this degree of freedom is 2, total is 3. In quantum where, in this case, two dimension is nano order, so degree of confinement is 2, degree of freedom is 1, it's total 3. In case of quantum dot, all dimensions is nano range, so degree of confinement is 3 and degree of freedom is 0, so total is 3. So it is the total overall concept of about this quantum confinement. Now this is the overall discussion about the concept of nanomaterials. So today I'll finish it here. I'll come to the next topics about the XRD, X-ray diffraction methods and Bragg's law. Those things we will discuss in our next video. Thank you.